In this video, we will be looking at some examples here on finding derivatives of certain functions, and then some pressures lifted off everybody. We do not have to simplify the answers. So starting here, I have f of x equals this function. Well, I can tell that there will be a product rule because I have the product of two different functions. And what that will look like is if you just take the derivative of this, it'll be the first function, so x squared minus 3x, times the derivative of the second function. So the derivative of tangent is secant squared plus the second function times the derivative of the first, which would be just using the power rule here. That will give us 2x minus 3. And that's it. Do not simplify means do not simplify. Don't rearrange anything. Don't multiply by any LCDs. Nothing. That's it. For the next one here, f of x equals x squared minus 3x to the 42nd power times sine of x. So this looks very similar to this one. So I already know that I will need a product rule. And I'm going to work this one out down here. And this time I'm going to choose to write out in the dx notation, as you should always do. I did not do it with this one here because I could see already that it was just going to be a product rule. But this one reveals a little bit of a surprise. So we have f prime of x will be the first function times the derivative of the second function plus the second function times the derivative of the first. So what will happen here is I will find the derivative of sine of x, no big deal. But the derivative of this piece requires a chain rule, because I have an inner function here. I have an outer function here. So the chain rule will need to be applied to this. This is why I wanted to write it out with this ddx notation here. And I suggest to everybody watching that you do this as well. So this will be x squared minus 3x to the 42nd power times cosine of x plus sine of x times, if you take the derivative of the outer function, that'll be 42. Leave the inner function alone. That's x squared minus 3x. And then you take the derivative of the inner function, and that would be 2x minus 3. And this big long expression here would be the derivative of the original function f of x. Along with this power 41 that was here that I missed very innocently. But here, just want to make sure that you all see this. This is a power 41 on this expression here. With that 41, now this is the derivative of this function. So here are some more examples. And again, we do not need to simplify these answers. So the first one I see here is g of x. So I'm going to find g prime of x. But before I even find g prime of x, I want to rewrite g of x like this. Secant 3x, the entire thing squared. That's what this square means right here. That being said, I can now see that there's an inner function and there is an outer function. What that means is that a chain rule needs to be worked out here. And with this chain rule, we need to take the derivative of the outer function. So here I'm going to set up g prime of x. And the outer function tells us that we just need to run a power rule because that is what is on the outer, on the outside. So we have 2. I'm going to have something here. I'm going to move this exponent to 1, and I will write it this time just so everybody can see what's going on. And then I'll have secant of 3x times the derivative of the inner function. From here, I can see again that I have a chain rule to write out, where 3x will be the inner function and the secant will be the outer function. All right, so we have to do a chain rule one more time, but we don't need to worry about simplifying anything that we've done here. So I am quite literally just going to copy this down right here. So I have 2 secant 3x times, let's see, take the derivative of the outside. The derivative of a secant function is secant tangent. And we leave the inside alone, so each of these will get a 3x times the inside function. The derivative of the inside function is 3. And I can tell here that when I look in this inner function, this 3x, there's no inside and outside. So I know that'll be the last place for this. So I have this answer for this particular function. And again, no simplification. Don't multiply 3 times 2. Don't try to combine these into a secant square. Just leave it as is, move on to the next one. Speaking of the next one, it's right here. We have h of x equals this nonsense. Well, that's a lot of nonsense. Let me rewrite this so that it makes more sense to myself. There we go. So because of how the spacing works on this page with how I've worked this out, I am actually going to come down here and work the derivative of h prime of x down here. So this will require a quotient rule. So let's go ahead and get into that. This will be the denominator. X cubed plus 2x minus 1 times the derivative of the numerator, which is 2x plus 3 to the 1/2 minus the numerator times the derivative of the denominator, which is x cubed plus 2x plus minus 1, all over the denominator squared. So x cubed plus 2x minus 1 squared. All right. So now the only thing we have left to do is to find these derivatives here, and we'll be done since there's no simplifying needed for these exercises. But like the example on the left, there is a chain rule that's going to happen right here. because I do have an inner function, 2x plus 3, and an outer function, the 1/2 power. But again here, the upshot is we do not need to simplify anything. So the derivative with these derivatives taken looks like this. So here we go, this part matches, but the derivative of this, we have to take the derivative of the outer function, so I moved the 1/2 to the front and subtracted 1/2 from the, subtracted 1 from the exponent, left the inside alone. Then I multiplied that by the derivative of the inside piece. Just by using the power rule here, you get 2. The second derivative over here is 3x squared plus 2. The 1 drops away. So there's that. And that's it. I get to circle this and be done. There was no reason for me to simplify my answer, as the directions told me so. So that's the answer. For this slide and the next, I'm just going to reveal some steps every few seconds that lead up to the answer, and I will talk about the entire process at the very end. And here is the final unsimplified answer. And there's a lot going on here. Well, the first thing we needed to do is rewrite this square root as a 1/2 power to make sure it was understandable for the purposes of derivatives. Then you had to notice that there is a quotient here. So we use the quotient rule. That's denominator times derivative of the numerator minus numerator times derivative of the denominator over denominator squared. Now, even though you can multiply these two numbers together and get 1 very easily, I'm a very firm believer in that you should just leave this alone, because this will probably save some headache from this step to the next, just in case you decide to add these two numbers and get it wrong. Then that would be marked as incorrect. So moving from this step to this step, you have to notice here with this derivative that there's a chain rule happening. So we have the inner function as x squared minus 2x and the outer function as 1/2 power. You take the derivative of the power first here, subtract 1 from the exponent, gives you negative 1/2, then you multiply by the derivative of what was inside. Over here on this other side, the derivative of tangent is secant squared, and that's it. This is what we end up with here. So something very similar that will happen over here with g of x. All right, here is the final answer for this particular function. It is just a 2 chain rule derivative, and you would not see that unless you decided to write out this ddx of this cosine 3x. So it is very important that you do that. That way you can see that over here, there's another outer and inner function. All right, on to the last slide. So for this last slide here, we have 2 more functions, and we are trying to find the derivative without simplifying them. So again, here we will have a product rule, and this time I am just going to jump into the derivative itself. So here we will have g prime of x, which will be involving a product rule. And I can tell that because of this multiplication here. I've got x squared and cosecant 2x. And so here we go. I will have the first times the derivative of the second one, and that is this piece. And as I take the derivative of this, I realize that there will be a chain rule with the outer function here and the inner function here. and that means I will have to take the derivative of the outer function first. And so the derivative of cosecant is negative cosecant cotangent, and the 2x stays inside untouched. And I will multiply that by 2, as that is the derivative of the inside function. To that, I will add the second function, which is cosecant 2x, and multiply that to the derivative of the first function. And so this would be it here. It's a little oddly notated, as I have this second example here that I would like to deal with. So it is this first term plus this second term here. For this second example, I see that I have an inside function here and an outside function here, or an inner and outer function. And so for the derivative of this, I will take the derivative of the outside function, so that'd be 20, and then whatever's left to the 19th power. And the inside function stays exactly the same. So this will be secant x squared plus x. And this one I will write out, so this will be d dx, the inside function, which is secant x squared plus x. And I want to write this one out because here we have a chain rule where this is the outer function and this is the inner function. But we also have this other term here, and with this term we just take the derivative using the power rule. So what that'll end up looking like is we will have 20 secant x squared plus x to the 19th power. And I'm just going to concentrate on this term right here next. So this will be multiplied by, let's see here, that would be secant tangent. That's the derivative of the outside function, and we leave the inside alone. And then we multiply that by the derivative of the inside function, which is the x squared. So the derivative of that is 2x. Then finally we can come over here with this plus. So this plus sign will be here. And to that we add the derivative of x as 1. And that's it. That is the derivative for this final function on this video. Again, I hope these are helping you out. I hope this is a good review for those of you who've seen this before. And for my students, I hope this is helping you get a better understanding as to how derivatives work.